In this video, we're going to review moments of inertia and how to find them. So just to review, when we were finding a centroid of an area, we calculated the first moment of area about an axis. And that has the form of an integral of x dA, where x is the distance to some small differential area dA, and you're summing over the entire area. So that's the first moment of area, about an axis. The second one has a similar form. So it has the form of an integral of x squared dA. And this one also has a different name. It's also called the moment of inertia. And so we will often call it that in our class, so the moment of inertia. So the moments of inertia are abbreviated as I sub x and I sub y. And where do we use these in fluid mechanics? Well, not just in fluid mechanics, but in other places as well. These terms are used when you need to find a moment but not just the moment of a linear load, but of a distributed load. That varies linearly from the moment axis. So in fluid mechanics, we often see this exact situation when we have pressure on the wall of a tank, for example. So we may have a tank full of water or an aquarium full of water, and it would look something like this, right? So we would have some wall. This could be the concrete wall of a pool. This could be some sort of a gate where we have water next to it, and pressure is going to vary linearly with depth. So at the top, we'll have a pressure that's equal to the atmospheric pressure, and then as we go deeper, that pressure force, the force due to that pressure, is going to increase linearly. So it increases with depth by the equation that we found earlier, which was the pressure is equal to P naught, the pressure at the surface, plus rho GH. Rho is the density of the fluid, G is gravity, and H is the depth of the fluid. So we see the situation in fluid mechanics, in fluid statics, and so for finding these types of distributed loads, we often need to use the moments of inertia. So I haven't given you the equations yet. So the equations for Ix and Iy are as follows. So Ix is equal to the integral over the area of y squared dA. And I sub y is equal to the integral over the area of x squared dA. Now you'll notice that these terms will have dimensions length to the fourth, right? We have a x squared, some distance, which is squared, multiplied by an area. That would give us length to the fourth. So for example, we would have, meters to the fourth, or, feet to the fourth. One other thing to note about the moments of inertia is that they will always be positive. To the power of 2, and therefore this term will always be positive.